Okay, good morning, everyone. First of all, let me introduce myself. My name is Dian Santiasih. My student number is 231301162 from class 6D. Today, I would like to present a topic in mathematics entitled geometric transformation. In this presentation, I will explain the basic concept of geometric transformation, the different type of transformation, and the coordinate rules used of each transformation. So let's begin. Okay, before we start learning about formulas, I would like to ask a simple question. Who can the position of a point on a plane change without changing the shape of the original feature? Think about moving a triangle from one place to another. Even though its position changes, its size and shape remain exactly the same. This idea is called geometry transformation. In mathematics, a transformation changes the position, orientation, or size of a figure according to a certain rules. After studying this material, we are expected to understand the basic concept of geometric transformation, identify the different type of transformation, apply the coordinate rules for each transformation, solve simple problems involving transformation on the Cartesian plane. This objective will help us understand how objects move mathematically without changing their essential properties. Okay, now let's move to the introduction. A geometric transformation is a rule that changes the position of a point or a shape on the Cartesian plane. The important thing is that most transformations do not change the original shape. Instead, they only change its position, direction, or size. Every transformation can be represented by changes the coordinate of the point. This makes it easily to analyze mathematically. Okay. There are four main types of geometric transformation. They are translation, reflection, rotation, and dilatation. Each transformation has its own coordinate rules. Let's discuss them one by one. The first type is translation. Translation means moving a point or a shape from one position to another without changing its size or direction. This simple slide is the feature if a point A x, y is translated by the vector a, b, then the new coordinate becomes a primes equal x plus a, y plus b. This means we add a to the x coordinate and b to the y coordinate. The size and shape of the feature remain exactly the same. The second type is reflection. Reflection is also called a mirror transformation. It flips a feature across a line. There are two common reflection. First, reflection across the x-axis. The rule is a x, y becomes x prime x, negative y. Here, the x coordinates stay the same, but but the y coordinate changes its side. Second, reflection across the y axis. The rules is a x comma y becomes a primes negative x comma y. In this case, the y coordinate remains the same while the x coordinate changes its sign. Next is rotation. Rotation means turning a feature around a fixed point. In this presentation, the center of rotation is the origin. There are three common angles. For a 90-degree counterclockwise rotation, a x comma y becomes a prime negative y comma x. For a 180-degree rotation, a x comma y becomes a prime x comma I'm sorry becomes a prime negative x comma negative y. For a 2000 degree counterclockwise rotation, a x comma y becomes a primes y comma negative x. During rotation, the size and shape of the figure remaining unchanged. Okay. Besides these standard angles, rotation can also be performed using any angle, which is we are usually represented by theta. In this case, we use trigonometric function, namely cos and sines. Since the new coordinates are calculated using the rotation formula. This formula allows us to rotate a point by any angle around the origin. Therefore, trigonometry plays an important role in geometric transformation. The last type is dilatation. Dilatation changes the size of a feature using a scale factor, usually represented by k. If k is greater than 1, if the feature becomes large. If k is between 0 and 1, the feature becomes smaller. If k is negative, the feature change size is and is also reflected through the center. Unlike the previous transformation, dilatation changes the size of the feature while maintaining its shape. To summary today's presentation, geometric transformation changes the position, orientation, or size of a feature. There are four main types: translation, reflection, rotation, dilatation. Its transformation follows its own coordinate rules. Understanding this rule helps us solve many geometric problems on the Cartesian plane. That's bring me to the end of my presentation. Thank you very much for your attention. I hope this presentation had helped you understand the basic concept of geometric transformation. If you have any question, I would like be happy to answer them. Okay, thank you. Have a nice day. Bye bye.